Hi, welcome to my video on defining an asymptote. An asymptote, definition of an asymptote, a line that the graph approaches but does not intersect. Let's do some examples. One example is the horizontal asymptote. Notice this graph is extended as it goes to the right. As we say, goes to infinity. It's going up and up and up. So the y is going to infinity. But as it goes to the left, as x goes to negative infinity, this graph is getting closer and closer, but it'll never touch. So the asymptote here is y equals 0. So this should be, if you think about it, a broken line, but because the x-axis I have a solid. Also, number 2, we have a horizontal asymptote. Again, as x goes to negative infinity, y is going to infinity. As x goes to positive infinity, y is getting smaller and smaller and smaller and approaching 0. So again, the horizontal asymptote here is the x-axis, y equals 0. And number 3, notice now that the graph has moved up. So notice that this is 1, 2, 3, 4, 5. This line here, dotted line, is y equals 2. So all the y values on this broken line is 2. But notice as x goes to infinity to the right, y is going to infinity. But as x goes to negative infinity, which is going to the left, y is approaching 0, and it won't touch it. So the asymptote is y equals 2. But notice the asymptote is a broken line, because even though the asymptote says y equals 2, remember, a broken line is representing that asymptote that is approaching it. Number 4, and we have negative 5 down here, so this is a negative 1. So this dotted line here is y equals negative 1. It's the horizontal line passing through negative 1. So as x goes to positive infinity this way, this graph is approaching this dotted line, but it'll never touch. It gets closer and closer. So the asymptote is y equals negative 1. So there's examples of the horizontal asymptotes, that the graph approaches, but it won't touch. Now, another type of asymptote is what we call the vertical asymptote. So notice that this graph, as x goes to negative infinity, y is going down to negative infinity. But as x goes to, notice, as x goes to 0, x is 0 right here. As x approaches 0, this graph goes up and up and up, but is not touching. So the x equals 0 is the y-axis. So the asymptote is x equals 0. It's approaching it but not touching it. And it's the same here, only as it goes down, as x approaches 0, here, coming at, I must explain, x is approaching 0 as I go into here towards 0. That means the graph is approaching negative infinity. So the asymptote is x equals 0. It's the y-axis here. It's approaching it. And notice here, it didn't say it, we're approaching 0 right here from the left side. So we're approaching 0 from the left. So here's a 0, so we're approaching 0 from the left. Over here, we're approaching to 0 from the right side. And now the asymptote is moved. So this asymptote here, that's a 1, 2, 3, 4, 5. This is x equals 3. This broken line is x equals 3. And so the asymptote, the graph is approaching this asymptote. So as you approach, notice, as you approach 3 from the right, it's going to infinity. And there's no asymptote. This is an asymptote as you approach x from the right. And so the asymptote is x equals 3. And we have an asymptote here. Notice, as you approach Notice this line right here is x equals 4. All values of x on this line are 4, but they're broken. They're dotted. So the asymptote is x equals 4. But we are approaching, notice we're approaching 4 from the left. There's the left. This is on the left of it. This is on the right of the 4. Oh, sorry. That's x equals negative 4. So as we approach x equals negative 4 from the left side, then we're going to negative infinity, so it's going down. So as closer I get to negative 4 on this side here, this goes down, 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 but it'll never touch. It'll never touch. Theoretically, it should never touch. But if I keep drawing it with a pencil, it will eventually touch it because the pen got thickness. Okay. And another type of asymptote is the oblique asymptote. Oblique is slanted. So I have an oblique asymptote and a horizontal asymptote, because you can't have an oblique asymptote by itself. So notice this line is oblique. This is the horizontal line, which is the x-axis. This is the vertical. Y-axis is vertical. But this is, notice, this is 1, 1, 2, 2. So this line is y equals x, because when x is 0, y is 0. When x is 1, y is 1. So this is the equation of this line, y equals x. So the asymptote is y equals x as an oblique. And notice, it's as x goes to infinity, the y value goes to 0. So another asymptote here is y equals 0, the horizontal asymptote. So there's two of them here. And as you do more math, you'll see where this comes into play. So let's state the asymptote of each of these. Let's look at this one. So notice that as x goes to infinity, here, y is going to 0. As x goes to negative infinity, y is going to 0. So y equals 0 is this asymptote right here. And as x, notice as x comes in here, going towards 0, the y is going to infinity, but it gets closer and closer, but it won't touch. So x equals 0 is the vertical asymptote. As x approaches 0 from the left side, y is going to negative infinity. As x approaches 0 from the right side, it's going to positive infinity. So the asymptote is y equals 0, which is right here, and this is x equals 0 right here. And this is very similar to here. So notice that this horizontal line, this is 4, the 3, 2, 1. So this line right here is y equals 1. Again, horizontal line is y equals, because all the y values on this broken line are 1. And this is x equals 2. And how do I know? Well, x is 2. All x coordinates on this line are 2. So these are the two asymptotes. So you can see it's going to, as x goes to positive infinity, this is going to 1. As x goes to negative infinity, this is going to 1. So the horizontal asymptote is y equals 1. The vertical asymptote is x equals 2. So as x approaches 2 on the right side, it's going to negative infinity. As x approaches 2 on the left side, it's going to positive infinity. That's the idea of a limit, and that will be discussed further when we do some work on pre-calculus. Now, to explain that a little bit further, find the value of 1 over x as x approaches. So I'm going to find the value of 1 over x. What's happening to this expression as x approaches infinity? So watch what happens. So if we take a 0 and put a 0 in, so 1 over 0 is undefined. So we can't. What about if we have 1? 1 over 1 is 1. Okay, what happens if we have a 10? So we have 1 over 10, so that's 0.1. What about we have let's pretend we went 100, 1 over 100. So when x is 100, we have 1 over 100, which is 0.01 as a decimal. And then we have, let's go to 1,000. So we have 1 over 1,000, and 1 over 1,000 is 0.001. So notice the decimal is getting smaller and smaller as x approaches infinity. As x gets larger and larger, this expression gets smaller and smaller and is approaching 0. So the answer is it's approaching 0. And what about as x approaches negative infinity? So what about if you have a 0 again? 0 for x will be undefined. But as you approach, let's say, negative 10. So 1 divided by negative 10 is a negative 0.1. So it's 0.1, this expression. As we do a negative 100, it's 1 over a negative 100. So it's a negative 0.01. And as we go to negative 1,000, it's 1 over negative 1,000, which is negative 0.001. And again, you can see it's getting smaller and smaller and smaller. And if we put a million here, like that, then we get 1 over approaching a negative a million, I should say, which is, there it is. So that gives you negative 0. And we got 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. Notice that we got 10, we got 1 decimal place. We got 100, we got 2 decimal places. We got 1,000, we got 3 decimal places, 3 zeros, 2 zeros. So if you got a million, then you got 6 zeros, so you got 6 decimal places. So notice the number, again, is approaching 0. So as x goes to negative infinity, this expression approaches 0. As x goes to positive infinity, this expression is approaching 0. What about if you approach 0 from the right? So 0 from the right. So let's put 0 right here. And let's start out here and approach 0 as we come in. So let's take the number line, I'm skewing it a bit here. Let's take 2. So if we're at 2, if we're at 2, we get 1/2. So this expression is a half. If we're at 1, put a 1 in here, we get 1 over 1, which is 1. Okay, what about if we have a 0? Well, 0, if we go to 0, what happens? We get 1 over 0, and it's undefined. So, what about the numbers between 0 and 1? What about if we take 1/10? 1/10 is, we go 1 divided by 1/10. That's the same as 1 times 10. So we get a 10. So if we put 1/10 in here, we'll get a 10. What about if we put 100? Now, notice 1/10, 100, we're getting close. So we put 100 in, it's 1 over 100. So that becomes 100. So I'm getting closer. So what about if I put 1,000? See, that's a 1 and that's a 0. This is 1/10, this is 100, this is 1,000. So I'm getting closer and closer to 0. So that's 1 divided by 1 over 1,000. So I get 1,000. So notice when I'm between 1 and 0, getting closer to 0 with this fraction, I'm getting, the number is getting larger and larger. So that means the closer I get as x approaches 0, 1 over x is approaching infinity. It's getting larger and larger. Notice we got a 10, 100, 1,000, etc. Now, to explain that in relation to a graph, and see if I can. So notice if we have a graph and we have a 2, well, if we have a graph and we say, if we say y equals 1 over x, if x is 2, then y is a half. Okay? If x is 1, 1 over 1, y is 1. Okay? If x is 1/10, so 1 over 1/10, we get a 10, which is way, let's pretend way up there. Whatever we got 1 over 100 is getting closer and closer to 0. 1 divided by 1 over 100 is 100, so it's gone way, way up. Whatever we got get closer and closer to 1 over 1,000. That means we're gone higher again. So notice as the graph, as I approach 0, the graph comes in and goes like that. But remember, it'll never pass through. So it's like this is x equals 0. So as x approaches 0 from the right, that means it's going to infinity. It gets higher and higher and higher, but it'll never touch the idea of the 1 over. So the larger x gets, the smaller 1 over x goes to 0. The smaller x gets, the closer it goes to 0. Or to infinity, sorry. Or we could also go, if it was negative, go to negative infinity. Again, repeat, if x gets larger, then it approaches 0. If x gets smaller, this is approaching infinity, if it's plus or minus. So what about if you approach 0 from the left, like this? So here's a 0. So that means you're on the opposite side of this. Think about this graph. This is x and this is y. So if you think about y equals 1 over x, here's the graph. So as you approach 0 from this side, so if you approach 0, you get a negative 1,000. So you get 1 over negative 1,000 is small. So it's decimal 0.001. As you approach, let's say we're coming into negative 100. So that's 1 over negative 100, which is negative 0.01. And as you approach negative 10, you get 1 over negative 10, which is negative 0.1. And we're coming in closer. So now notice as we approach negative 1, it's 1 over negative 1, which is negative 1. And as we go to, say, negative 1/10, now we're getting closer. So it's 1 over negative 1/10, which is negative 10. So as you can see, it's getting larger and larger, but it's not getting like here. It's getting like 10, 100, 1,000, etc. is going to infinity. But this is going to negative 1, negative 10. So this one is going to negative infinity. So if you look at this graph here, so if you think about it, in relation to the decimal, if I got a negative 100, so I have decimal negative decimal 0.1. If I got a negative 10, then I got a negative decimal 1. So it's doing this. So the closer, as you approach 0 from the left on this expression, the closer you move to 0 on this side, then it's going down to negative infinity, verified by these numbers. So I want to explain that because that's very important when we're doing the idea of a limit. And a limit is what the value approaches. So this is a very similar concept to that. You'll see me do that later. So that explains roughly about asymptotes, vertical, horizontal, and oblique, and the idea of 1 over x. And again, if you like my video, click the like button. If you're not a subscriber, you wish to subscribe, do so. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.